Hello students, and welcome to our first lesson in general maths for the year. Today we're going to be looking particularly at percentages and decimals, and we'll finish off next lesson in rates. So today we want you to be able to apply percentage increase or decrease in various contexts. So for example, calculating percentage context, we're going to look at, for example, with pay increases, discounts, GST, and in a few lessons times we'll build into using percentages in income tax. So first of all, when we want to convert to a percentage, we'll often find things as either fractions, rates, or decimals. So if we see a fraction, for example, 3/4, let's just remind ourselves that this vinculum is actually just meaning divided by. So if we want to convert a fraction into a decimal and then into a percent, what we would say is 3 divided by 4, that would give you 0.75. Now to convert that into a percent, you would need to go 0.75 times 100 over 1, and that would give you 75%. Now I would just find that easier to move the decimal place 2 places. That's the beauty of our metric system, and multiplying any number by 100, you can just move that decimal place 2 places. Now rates are much like a percentage, where you see this out of 3, for example. So we're just saying 2 divided by 3. So for every 3 we have 2, or 2 out of 3. And you'll find that's 0.66 reoccurring. And what we'll then have to do is move that decimal place a couple of places. We're doing it to 1 decimal place where necessary, so that's going to be 66.6%. We can also round that off to 66.7% because 0.666 reoccurring rounds off to the 0.7. Now finally, the decimal, that's going to be very straightforward to convert to a percent. So we've got 0.0345. We're going to be multiplying by 100. So we can just move that decimal place a couple of places. So let's have a look what we're saying. So it's going to be 3.45%. We want it to 1 decimal place, so we're going to round that up to 3.5%. Now if you wanted to use your calculator, you would just go 0.0345 times 100, and you would come out with 3.45, and then you would round that up to 1 decimal place because that's what the question was asking for, to 3.5%. If we're looking at mixed fractions, these are going to be percentages greater than 100%. So in this case, 5 3/4, we would have to think of this as, so this is what we call a mixed fraction. We have to convert to an improper fraction. So what am I saying? I'm saying 5 equals 4 over 4 plus 4 over 4 plus 4 over 4. Remember, 4 over 4 is just 1, plus 4 over 4 plus 4 over 4. And we've got that 3/4, which is 3 over 4. Now, if I'm looking at that, that's quite a difficult, it's quite tedious, I suppose, to do it that way. So I would just go 5 times 4 is 20, plus another 3 equals 23/4. Now, I would then just go to a calculator, and I just say 23 divided by 4, which is going to be, resuming that, so 23 divided by 4 equals 5.75. Now, I find it easier just to move the decimal place a couple of places when I'm multiplying by 100. So I could say that's 575%. If you're not sure about that, you just go 5.75 times 100 over 1 equals 575%. Now, if I wanted to convert this number, which is greater than 100, so it's just 23.4, and let's multiply that by 100. So that's just 2340. So I am just moving the decimal place and putting in the 0. And so that's 2,340%. Now, if I want to increase or decrease a quantity by a set percentage, I can do it a couple of different ways. So the first of all is just through the use of a scale factor. So for example, if I want to increase 100% by 20%, I've actually got 120%. Now I can also simplify that to 120 over 100, so 12 over 10, and then I can also simplify that to 6/5. If I want to decrease 100% by 15%, I'm just reducing 100% by 15%, so that's going to be minus. So that's just 0.85 or 85%. Now, if I want to express it as a fraction, that's 85 over 100, and I could simplify by dividing both the top and the bottom by a common factor, and that would be down to 17/20. So let's consider two different methods of modelling percentage increase and decrease. So the first method I want to consider with you is the example that, for example, we've got a bull in a paddock, and it's a 900 kilogram bull, and it increased its weight over one summer. So we want to consider what's the final weight. So what do we want to know? We know that it started off at 100%, but it increased, so I'm putting a plus in, by 20%. So what I'm really saying is it's increased by 120%. So I just need to multiply that by 900 kilograms. And that should then give us about 1,080 kilograms. So 1,080 kg. Now, if I want to have a look at a discount, that's a reduction in percentage. So we're saying 100% minus 35% now is going to be multiplied by $120. So let's have a look there. It's what we're really saying is 65% of $120, and that should give us $78. Now I can also do this with a two-step process. So what we do is we add or subtract the percentage from the original quantity. So what we want to do here, 900 kilogram bull, increase its weight by 20% over one summer. So we just need to find out, well, what's 20% of 900 kilograms? So 2 9s are 18, so is that 180 kilograms? So that's step one, and then step two is to put that onto the original quantity. So we just say 900 kilograms plus 180 kilograms equals 1,080 kilograms. If I were to go to look at the next one, the percentage decrease, because it's a discount, so we're saying 35% multiplied by $120 should give us $42. Then we subtract it from the original quantity, so $120 minus $42 should give us $78. Now, if we want to find the original value, what we need to do is to consider that we do not know what the original value is, and that might seem obvious, but let's have a look at this example. So we've got a pair of pants bought for $30. So that $30 actually equals the discounted price. So we don't know what 100% of the price is, but we do know what 30% of the 100% price is. So we know that the discounted price is actually only 70% of the price. So we go 100% is the original value, but we need to take away that discount. Now, so 100% take 30% of the original value. I'm just going to put OV, just to be efficient, equals the discounted price, and that's $30. Now we can do a couple of different ways to calculate this, but I think it's probably easiest if we think about our one-step algebra. So we know that 70 over 100, which is what I'm saying right here, that's this concept here. 100% take 30% is 70%, which is the same as saying 70 over 100 times the original value. Oops, get back to my real pen. Let's times the original value equals $30. Now I've got this problem of this multiplied by here. So I've got an unknown, unknown, and unknown. And I want to bring all my knowns onto one side of the equal sign. So I'm going to have to move that to there. Now the opposite of times is divide. So I'm just going to divide. So over here now, $30 divided by 70 over 100. And we'll quickly do that on our calculator. 30 divided by 70 over 100. Now that will equal $42.857. Now that doesn't make sense because we live in a world with rounding. So we say that if you're going to the shop and you're going to want to pay the original price for it, we just round it off to 42.85 cents. You don't pay the 86 cents because we just round to the nearest 10 cents. That should do us for the day.